let's now fill in the input data for this simulation. You can go from any order. You can start with mesh or boundary conditions. I just like to work from top to bottom. So let's start with the computational domain. After we finish the wizard, the computational domain was created. At this point, I like to adjust it to how I'd like it. As you saw, if you select it, the grab handles appear, so you can simply just stretch the computational domain that way. Or if you right-click and hit Edit Definition, you can input the size. Here you can also define whether it's a symmetry on each face of the computational domain. Now we can work here from the tree, hit right-click, edit, but a lot of the options are also available here in the ribbon. Typically you'll see me in the videos working from the tree, but they are available here. For example, the computational domain is right here as well. Okay, so let's adjust it quickly here. You can just grab the handles. If you click on Shift on your keyboard and then click and drag, both sides will be adjusted. And I'll adjust it on all sides here. That wasn't even, so let me just make that one there. And gravity is pointed into the X direction. So let's adjust the bottom here and then leave the top a little bit bigger for the natural convection air to get fully developed. Okay, once we are happy with the computational domain, we can just right-click, hide, no longer have to see it in the display area here. Alright, next down on the list, fluid subdomains. We're not doing any water cooling or anything like that here, so we don't need to introduce a second or third fluid, so we'll leave that. Solid materials. Here, let's define these gap pads with the solid material. We can do so by right-clicking on solid materials and hitting Insert Solid Material. Before I do that, actually, I should mention, if your CAD model already has material properties, you can import data from model, meaning it pulls in from the Creo material database. Now, if it has thermal material properties, then this could save you some time. But here, we'll do Insert Solid Material. And first, we need to select the objects. So a couple ways to do this. One, we can simply just select them here visually by clicking on them. And as you can see, it's being selected here. Or, let me start over here. You can go to your navigation tree here and just simply select them in the tree. For the material type, there's already some user-defined material I'd like to select that was saved in the engineered database. So I'll go ahead and select that here and hit OK. So now in our tree here, we can see that the gap pads have been assigned to this material here. And if you click on it, you can rename this material if you'd like to. Now for the enclosure, remember that we already defined a material for the whole model in the wizard, so we don't need to define that. Which, by the way, you can access all the settings that you set in the wizard under General Settings. So if you open that up, you can go through all the properties that you've changed in the wizard here. So your physics, your fluids, and if you don't recall what we had set, we had aluminum for the material. So everything that's not specifically defined under solid materials here will be aluminum. Next, we have boundary conditions. We're not going to insert any boundary conditions here for this model, but this is where you'd introduce some kind of forced flow, whether you're attaching it to a fan, for example, pressure openings, and so on. So we don't need that here. Next, we have radiative surfaces. Now recall, in our general settings, we already have a radiative surface for the whole model, where we selected an aluminum. And that's okay for me in this model, but let's say you did want to select different surfaces to have different radiative properties. You can do that here. You can select this face and select a different radiative surface here. Next, we want to set up our goals. And you want to set your goals for your parameters of interest in your project, right? So for example, let's say you have a die in your model. you want to know the average temperature of that die. You can set up a volume goal for that, and this helps you in multiple ways. One, you get to monitor the convergence of that goal as your model is solving. You get to see the value of that goal. A second benefit is that you can set your solver to stop once particular goals are converged. Okay, so this could decrease your overall solution time, right? So for example, if your die has already become steady state, the temperatures are not fluctuating, there's no need to continue to solve for maybe some fluid phenomena in the opposite corner of your model that FloEFD is still trying to find convergence for. Also, you can use the goal to export the overall results and display them, or export them to spreadsheets, for example, after the solve is done. So the available goals you have here are global goals. This would be for everything inside the computational domain. Point goal, you can specify a point on a particular area. Surface goals, volume goals, and equation goals. So equation goals can be used for something like, for example, the difference of something. So for example, your inlet pressure versus your outlet pressure, and you can specify an equation to subtract them so you can have your delta P. Here, let's specify some global goals. Let's do temperature solid for minimum, average, and maximum for everything inside this solution domain here. And notice that use for convergence is checked. So the FloEFD solver will stop once these goals are converged. Another example here of a goal could be mass solid maximum. For example, let's say we were to change the geometry of these fins on this enclosure. The overall mass will change. So this, if we check this, it's a great way to monitor and export what was the total mass for that enclosure.